All right, y'all, let's finish up notes B3. Let's continue on with part 3, linear apps. So let's discuss some definitions first before we get the problem started. So independent quantity is the words that describe the independent variable. The independent variable is the letter that represents the independent quantity. The independent quantity's units are the units of the independent quantity. For example, if your independent quantity was time, then possible units for that independent quantity would be years, minutes, seconds, etc. Something that deals with time. Okay, your dependent quantity is the words that describe the dependent variable. Your dependent variable is the letter that represents the dependent quantity. And your dependent quantity's units are the units of the dependent quantity. So for example, you might have a dependent quantity of distance traveled, and in that case, possible units would be miles, yards, inches, etc. Of course, you wouldn't be working with all of these at once. It'd only be one of these. It just depends on the given problem. So hopefully that kind of makes sense, but hopefully, if not now, then by the end of this example, you'll be feeling a little bit better. So follow along with me on this problem, and I'll kind of show you where I got some of this stuff that I wrote on the sides here. I just wanted to kind of speed it up and have some pre-written information. So example number 1, and actually the only example we're going to do because it's lengthy. So let's read this together. The cash flow per share for the Timberland Company was 20 cents in 1995 and $4.20 in 2003. So let t equals 0 correspond to the year 1995. That's how I got this t equals 0 here. So t equals 0 corresponds to 1995. So let's go ahead and fill in a little bit more information. And if t equals 0 corresponds to 1995, then t equals 8 would correspond to 2003, because 8 years have passed to get from 1995 to 2003, or in other words, 2003 minus 1995 would be 8. Don't you agree? Okay, so then what it's wanting us to do after giving us that information is to find a linear model in slope-intercept form. So recall that slope-intercept form is y equals mx plus b. So that's definitely linear, we know that. So find a linear model in slope-intercept form giving, so a linear model giving what? Giving the cash flow per share C in terms of the year T. So that's basically saying this, C in terms of T. We are wanting to find C, the cash flow per share in terms of T. What is the slope of the model? So it's asking us for a model, what is the slope of the model? That's kind of redundant only because we have to find the slope to get this slope-intercept form, but we'll also kind of answer this separately. And then explain its meaning in the context of the problem. That means explain the slope's meaning in the context of the problem. And then we'll use our linear model that we find to estimate the cash flows for the years 2008 and 2010, because all we have right now is 1995 and 2003. So I guess it wants us to find a couple more years. Okay, so another thing that I wrote down here just to kind of help you with this vocabulary is just something you learned way back when in probably Algebra 1. So remember that when you're dealing with x and y depends on x. Of course, like everything we kind of have learned has always been in terms of y and x, like slope, y2 minus y1 over x2 minus x1. Of course, when you're dealing with real world scenarios, likely you won't be given like x and y. So we kind of have to transition what we learned into the variables that we're given to work with here in this scenario. So the variables we're dealing with are c and t. So remember, we're finding c in terms of t. So t would be our independent variable, right? Because c depends on t. So let's go ahead and write that down. So for our case, so we don't get confused kind of going back and forth between x and y, we'll say in our case, c depends on t. Well, what does that mean? Well, this always helps me to kind of see it. So let's draw, that's not very straight. Let's draw a like first quadrant graph here. So this is just quadrant 1, okay? Because it's a real world scenario, and likely in this real world scenario, all we'll be dealing with is positive x's and positive y's. We don't care about any of this negative junk, right? So typically we say y depends on x. This would be our y-axis, our x-axis. But let's label this according to our c and t. So c, remember, is our variable for cash flow per share. So actually our dependent, c is our dependent, c depends on t. Our dependent quantity, remember the words, the dependent quantity are the words. The words are cash flow per share. Okay, so that's what we'll write here to kind of label our graph. Cash flow per share. Okay, so that's our y, our dependent quantity. Cash flow per share, and then I usually do comma. So I've got my dependent quantity. Now what's the dependent variable? That is C. I got it here or here. I'm gonna put it here. And then I usually do comma, and then what is our dependent quantities units? So in this case, what is our cash flow per share? What's the units for that? What is it in? It's in dollars. Our cash is in dollars. So you can either write the word dollars or just do like the dollar symbol. Okay, so that's our dependent quantity. Now let's talk about our independent quantity. So our independent quantity is what? So you're thinking, well, my independent variable is t. What does t represent? Years? No, that's the units. Okay, so the t represents time. So our dependent quantity is time. Did I say dependent? I meant independent. I'm so sorry if I did. Our independent variable is t, and our independent quantities units are years. Okay, so that's kind of over here. So years. Alrighty. So now that I've kind of got everything labeled and hopefully kind of understanding, let's kind of even go further. So how are we going to find, why did we even care about this? How are we going to find our slope and our y-intercept? Well, what did it give us? It gave us these values at t equals 0, this value at t equals 8. Well, what are those? As far as we know, those are ordered pairs, okay? Those are points on the graph. On this linear model. Okay, so we're typically used to seeing something like ordered pairs as x comma y, but in this case it's going to be like t comma c or t comma c of t, right? So either way. So our first ordered pair is going to be our t equals 0. Doesn't really matter which one you put first, but I'm just kind of doing this one first because it appeared first. So t equals 0, where c of t, the cash flow, was 20 cents. And our second ordered pair is 8 comma 420. Okay. So then when I look at my information given, I say, oh, well, number one, this is the y-intercept. Okay, that's where t or x, whatever, is 0. So that's my y-intercept, 20.2, well, not 20, but 20 cents, all right, 0.20. That's my y-intercept. But to find my slope, remember, I need to use my formula. So let's recall slope formula, change in y over change in x, which in our case, again, let's switch the variables just so it makes more sense for us. In our case, change in c over change in t. Okay, so change in c over change in t, I want to deal, me personally, I want to deal with positive values. So I'm not going to do 0.20 minus 4.20. That's going to give me a negative answer. I would rather do 420. And remember, it doesn't matter which order you do it in as long as you stay consistent. Okay, so if I do 420 minus 20, then I've got to do 8 minus 0, not 0 minus 8. If I would have done it the other way around, 0.20 minus 4.20, I would have had to do 0 minus 8, which would have been a negative over a negative, which would have made a positive either way, just like this. But still, I just prefer, if I can, to work with positives. I'm sure you probably do too. So 420 minus 20, 0.20, 4.20 minus 0.20 is 4. 8 minus 0 is 8. Let's simplify this, make this 1/2. But just because of the context of the problem, kind of look at our outputs here. And just remember, We're talking about dollars and cents type of thing. So let's go ahead and convert this to 0.50, so kind of 50 cents. So then that will help me see that this is 50 cents. Remember, the units for C are dollars over per our units for T, years. Okay, so in the last part of this problem, I always like to kind of give the units for each. So that was, again, kind of 2 birds, 1 stone, because I answered the question of what is the slope? Right here, I answered that question. And then I'm about to use this information to fill in my model. So my linear model, C of T, equals my slope. In my model, I'm not going to use the units because we're just writing the equation here. I'm going to say 0.50 t. So I filled in my slope, okay, plus my y-intercept is 0.20. So that is my linear model. Okay, so I've got my linear model in slope-intercept form. I've got my slope. Now let's explain the slope's meaning in the context of the problem. What does this slope mean? What does it represent? Well, it's a positive slope. So if you're thinking about this graph, it's some kind of positive slope. It might not cross through the origin even though it looks like it, but it is a positive slope. So what does that mean? So we're gonna describe it. This slope shows, means, represents, something like that. This slope means what does it mean? What's happening? The cash flow per share, the cash flow, see, that's why it helps to have this kind of model here. The slope means the cash flow per share. What's it doing is it's increasing. We had a positive slope, so the cash flow per share is increasing by, we got the amount, by 50 cents. And I'm going to write it this time per year. Okay, instead of just like drawing the fraction, I'm going to write it out. So 50 cents per year. Okay, so that's the explain the meaning. Now we can answer the last question. Use the linear model to estimate the cash flows for the years 2008 and 2010. So essentially, we have to be cautious. I'm kind of going off the screen there. Essentially for 2008, kind of do that one right here, and then 2010, we have to be cautious. What we're finding for 2008 is, remember, we have to find that in terms of T. So in terms of T, 2008 would be T equals what, 13? So that would be like finding C of 13. So C of 13 would equal 0.50, where I see T, plug in 13, plus 0.20. Okay, kind of squiggly that. So that would be half of 13 is 6.5. 6.5 plus 0.2 would be 6.7. Excuse me. So the cash flow per share in 2008 would be $6.70. Okay, while 2010 would be equivalent to T equals 15. So you're evaluating C of 15, so 0.50, plug in 15 here, plus 0.20. I'm just plugging into my model, my linear model. So that's going to be half of 15 is 7.5. 7.5 plus 0.2 is 7.70. So $7.70 in 2010. Do these make sense? Really quick, I don't want to make this too long, but do these make sense? Well, the slope, let's talk about this, y'all. The slope is showing that the cash flow per share is increasing by 50 cents a year. So in 1995, we started at 20 cents. By 2003, so 8 years had passed, we're at $4.20. So what should happen in 2008 and 2010? Those values should definitely be bigger than $4.20, which they are. And then of course, in 2010, that should be a larger value than 2008 because we have a positive slope. So hopefully that kind of makes sense. And we're definitely going to get some more practice in class. So see you soon.